My name is Yohei Yokosuka from Kagoshima University in Japan. I would like to talking about Gridshell structure, discrete curvature line, modeling technique and evaluation of mechanical performance. It is possible to generate discrete curved surface with extremely good property by Möbius geometry and Laguerre geometry. These curved surfaces, excellent fabricability and workability can be constructed. In this paper, we introduce formulation of Lie sphere geometry and method of modeling for grid shell structures. We demonstrate structure analysis of curved surface. Line geometry classified geometry by operation of transformation on a set. Lie sphere geometry has a large group in Klein geometry. It considers point and plane as part of spheres. Curvature line coordinates are conserved by Lie sphere transformation. We derive Lie sphere geometry is necessary for our method bring significant formulation of circular nets and concept about Klein geometry. This slide shows sphere S and plane P as shown in equation 1, 2, 3. We regard a point x as an oriented sphere of radius 0 centered at x. Let us consider six-dimensional space R6 with natural basis as equation 4. Take a vector equation 5 has 6 components. Then we can check this equation. Note that the right side is equation 2, 0. This fact suggests us to introduce this scalar product. Thus, we may identify an oriented sphere S with a point S hat of R6. Thus, an oriented sphere S hat satisfies S hat product S hat is equal to 0. Two oriented spheres S1 and S2 are in oriented contact if and only if S1 hat product S2 hat is equal to 0. These equations are fundamental equations to generate circular nets. Left side figure show one unit of circular nets. When four center points of sphere are given, to solve equation 6, we can generate one circle of nets. Right side figure show Möbius and Laguerre geometry. Lie sphere group contains Möbius transformation as well as Laguerre transformations. Curvature line coordinate and curvature line net are conserved by Lie sphere transformation. It is expected to be useful for generating curvature line net. This slide shows modeling technique for circular nets. First set of 4 center points constitute minimum unit. Second, network of center points are expanded to two directions x, y. Support points of curved surface are defined always in same plane by mirror reversing coordinate value of constituent node in consideration of symmetry condition. When network expand, plane including center point is rotated to solve nonlinear equation, find a new center point. This is an example of the region. Rotation of a plane is expressed as this equation. Center point CK is found by solving nonlinear equations. If all center points are found, all radius can be found also. Constituent node of circular nets can be found. This slide shows a table of symbols. Formulation of region of M is equal to 1 and N is equal to 1 is shown as this slide. Initial value and specified values are shown like this. These are next initial values. Formulation of this region is shown in this slide. These are nonlinear equations. To solve these equations by Newton method, we can find this unknown value. Similarly, formulation of this region can be derived as shown this slide. This region is different from before regions, but we can take three unknown values to solve three equations. By finding center points and signed radius of all oriented spheres, constituent nodes of circular nets can be found by this equation, obtained from indicated in the slide. From these results, circular nets can be obtained by solving nonlinear equation formalized by Lie sphere geometry. By giving different parameters, these results can be found. This slide shows how Gridshell structure is generated by a circular net. Circular net is subdivided in the direction of principal curvature. Method is shown as following: first step, second step, third step. Repeat these steps to generate the Gridshell structure. This figure shows Gaussian curvature distribution. This result is considered as a discrete curvature line in which discrete curved surface is subdivided along curvature line. Therefore, it is possible to construct a curved member by bending only one axis. This grid shell structure has a property of excellent fabricability of members. This slide indicates structure analysis for shell structure using finite element method. Structural forms obtained by circular nets are investigate how stressed state generate considering principal bending moment and principal membrane stress. We compare two loading case. Case 1 is normal loading. Case 2 is vertical loading. Structural analysis in this paper utilizes simplate theory based discrete Kirchhoff theory. From result of case 1, normal loading does not generate bending moment on center area of curved surface. On the other hand, from result of case 2, vertical loading generates bending moment extensively. Principal membrane stress are generated along curvature line in case 1. However, it is disturbed near boundary. These results indicate similar mechanical performance of the class of all surface from reference 4 and 5. This slide shows the conclusion. We confirmed Lie sphere geometry is useful for Gridshell structures. Thank you for your attention.